One thing that we didn't get when we asked for exercises on vectors was an exercise that involves nested vectors. So a vector whose elements are also vectors, or I mean, just to sketch it out, something sort of like this. So I think it might be worth it to see if ChatGPT can help us out and generate a couple of exercises just about this case. And maybe what it generates is hideous. Maybe I won't do all of what it generates, but we'll see what it comes up with. In general, for myself, I always have found that coming up with good exercises for nested or for 2D arrays or for nested vectors is a bit challenging. So actually, I'd be rather grateful if it comes up with anything. I'm learning C++ 20. I've learned so far about vectors, strings, and basic I/O. Can you suggest, or can you generate 3 programming exercises involving nested vectors? And just in case you doesn't know what I mean by that, i.e. vectors of vectors. Don't show me the solution. Of course! Working with nested vectors in C++ can help you grasp the concept of managing Yes, of course, that's why I'm asking. Exercise 1. Write a program that takes in an n by m matrix as input and uses nested vectors and prints its transpose. Okay, that's a solid exercise. So we can represent a matrix using nested vectors. Jagged array operations. Create a program that allows the user to perform various operations on a jagged array using nested vectors. Okay, this is a bit too open-ended. It just gives me a sketch of some ideas. Exercise 3, Pascal's triangle. Generate and print Pascal's triangle up to a certain number of rows. This is actually an exercise that I've already done elsewhere. So I'm gonna veto this. I actually sort of like exercise 1. What I feel like I should do though for exercise 1 is, it's gonna take me a long time. I mean, the point of this exercise for me as practice is to work with nested vectors. It sounds like I'll have to write a whole bunch of test code to get this to work. I'm gonna ask it if it can expand exercise 1. I like exercise 1. Can you generate an expanded version in the following form? The exercise consists of starter code with several functions involving nested vectors missing for me to implement. The main function contains some test cases for each function. And then I'm going to say, don't show me the solution. So I'm basically going to ask ChatGPT to design a sort of assignment template for me, including main with some test cases. Because if I want practice with nested vectors, I don't want to spend a huge amount of time trying to write out a bunch of matrices. I just want to do the exercise. So we'll see what this does. In the past, it has worked when I've asked it this, but I often have to give it quite a bit of prompting to make that work. All right, certainly. Here's an expanded version. What do we have? Okay, that looks nice. That's a nice, I think, a civilized exercise. It didn't add too many functions, but I think that works. Okay, so let's grab this template and then see if it compiles, I guess, because who knows if that's going to work. So we'll head over here. I'm going to replace all of my code with the template that it generated. I'm just going to save that. I'm going to try running it. All right, so this warning looks like something I could ignore because it looks like it's just a function that I have not written yet. All right, and I'm going to make one editorial change to the exercise because you probably do know about this feature by now because it's next week's material, but I'm going to delete this. I'm going to make the executive decision to delete this ampersand because nothing will change about the exercise if I do that, and because maybe it's confusing to see it there. So I think, and I'll prove it, I'll see if I can still compile the code if I do this. Okay, so we can see here that it still gives the same warning. This warning is just that I haven't written one of the functions, so fair enough. In main, I've got here's a matrix. It's decided that the matrix has element type int, which I think is sort of bizarre. I mean, it's weird that it would go there, but fair enough, whatever, that's what the exercise says. I then call print matrix to print out the original matrix. I call a function transpose matrix to compute the transpose, and then I call print matrix to print that out. Now, if I run this, I expect that probably nothing will happen, or maybe the program will crash because it's not... Yeah, it does nothing because neither of the functions have been written. So of course, what I should do is first I should try printing out the original matrix, because that way, without printing code, how will I test anything? All right, so what exactly is this? So the variable matrix is a vector of vectors. And I'm assuming, because of the way that we created the vector, so this is a vector of vectors. And the initializer, oh, actually, I don't like that initializer. Another editorial change, I'm going to write the initializer with no equal sign. So it's written an initializer that looks a lot more like a C-style array initializer. Okay, so there it is. This still works. This is closer to what we would do in this course. So you can see here that the initializer for the vector, it contains three things, and each thing is the initializer for another vector. I read this to mean that this vector of vectors is a matrix where each subvector, so each element of my outside vector, is another vector that represents one row of the matrix, which means if I want to print out the whole matrix, I will loop over the elements of the matrix itself. Each one is a row, and then I'll loop over the elements of the row to print them out. Okay, so to model that, I might write something like this. For, let's do, I'm going to also remove the word const. This has to do with the fact that I don't want to use the auto keyword, and I just don't want to, I want to work around the word const for today. Next week and every week after that, we will keep the word const in. We just want to ease in. So for each element of the matrix, okay, what's the element type of this variable? It's whatever in the angle brackets. So it's going to be one of these vectors. For this, each row in the matrix. Now that ampersand that I removed actually would be quite helpful if I were trying to solve this in any other context. Generally, looping over a vector of vectors, you would write it with a bunch of ampersands in various places, but it should still work without that, so I'm going to do that. So for each row of the matrix, I'm going to loop over the contents of that row, so for each int x in the row, and then I'm going to print that out. And then I'm going to print a new line at the end of the row. So cdc out gets x, and then it gets a space. And then when I'm done the row, I'm going to print out a new line. All right. I'm going to see if this runs. Now, what's weird, although the code already ran and did nothing, now that the code works with the matrix, this will probably crash the way it's currently written. I'm going to try that. And yeah, it crashes. We're going to ignore this crash. It's trying to print out the transposed matrix, even though the transpose function doesn't do anything yet. That's basically the reason. You can see it's giving a cryptic error. We won't worry about that. But notice how the matrix did get printed out. And I'll bet that if I were to change something, it would also get printed out. So we'll change that to 10. Okay, so I think at this point that my print matrix function works. If I don't believe that, then I could also, I could maybe see what happens if I use a matrix of where the number of rows and the number of columns aren't equal. So we'll just try that. Okay, there we go. We'll just run that. Okay, so it does seem to print it out. The alignment's a bit off, but that's fair enough. That'll do the trick for our purposes. For the sake of working with this, I am going to change these to all be one-digit numbers just so it looks cleaner. So there, we'll try that. All right, looks like it is printing out. Now, how do I transpose the matrix? So I think what I need to do is the transposed matrix, if I take a 3-row, 4-column matrix, I should get a 4-row and 3-column matrix. And so I guess the first thing I should do is figure out the row count and the column count. So how many rows are there? Well, each entry, this is a vector of vectors, each entry of matrix is 1 row. So the number of rows, so I'll just take unsigned int num rows. This will be the number of rows in the matrix, the original input matrix. That's going to be equal to matrix.size. And the number of columns is the size of 1 row, which would be, so 1 row would be an element of the outside matrix. So unsigned int num columns equals matrix.at1, so let's say the first row, and then take its size. One thing I'm not doing here is considering what happens if the user does something weird and has 1 row be a different size than the others. I would interpret that to be their problem. Like if they're representing this as a matrix to me, then I should assume that the matrix is rectangular, that there's not weird jagged rows happening. So I'm going to assume that. I'm not going to do error checking. I could verify that every row has the same length, and you can imagine how I might do that. It's not too complicated, but I'm not going to do that here. Okay, so now what I'm going to do is I'm going to make a new vector of vectors. So vector of int, and it's going to be called t for transpose. What I'm going to do first is I'm just going to add, I'm going to create an empty matrix of the right dimensions. So the number of rows in t is equal to the number of columns in m. For the sake of making that easier for me to understand, I'm going to say t rows is equal to the number of columns in m. And unsigned int t columns is equal to the number of rows in m. Because that way when I loop over it, I won't need to write columns where I mean rows. I'll just write t rows where I mean the number of rows in t. Now I'm going to iterate up to the number of rows and columns that I want and just add all of those things to t. So unsigned int I is going to be 0, I is less than t rows, I plus plus. And so what I'm going to do is make the row, so create a row and add it to t. So I'll make a row. The row is a vector of int, so I'll call that row. And then when I'm done, I'm going to say t.pushBack and just push the entire row into my vector. And then I have to create the row. So I'll do that by doing for unsigned int j. J is going to start at 0. J goes up to the number of columns in t, and j plus plus. And then I'm going to just do row.pushBack 0. So the idea here is that this way I'm making a matrix of the right size. Notice how this is pretty verbose. There are clever tricks I could use to make it take less time, but they require memorizing features of the library, which it's faster for me to just write this loop than to go and remember all the other ways to do this. And so I'm going to make an empty matrix, and then I'll just go through and loop over my original matrix to fill it in, because I know how to set the elements of a transpose once I have them, but I need to make the transpose big enough. For now, I'm going to return t empty. So I should get a matrix of the right size, the right dimensions, but full of zeros. So we'll try that. It's looking like it's very upset about this. Oh yeah, okay, that's a, yeah, okay. So I could use the auto keyword here. I am going to, just for the sake of keeping things moving, instead, I'm going to sort of shirk this a little bit. I'm going to write this. So what it's complaining about basically is that unsigned int isn't the real type of matrix.size. It's long unsigned int, or in general, it could be all sorts of weird stuff. This is not a complaint I need to be worried about in this context for reasons that are not really relevant to this situation, but basically because it's never the case that my matrix could be large enough for this distinction to make a difference. So to get around that error, I'm just going to slightly modify my code so that the compiler cares a little bit less about it. I acknowledge that what I'm doing is a little bit sort of underhanded, but it's a way of just focusing on the actual exercise we want to do. If you care about the distinction, come by the office hours. Okay, so my transpose matrix has 3 columns and 4 rows. That looks good. Now what I want to do is loop over the original matrix or whatever, loop over one of the matrices and then set the elements in the other. So I'm going to do this with, I'm going to loop over the original matrix. So I'm going to loop over my original matrix, and then for each element, I'm going to set the corresponding, I guess, the reflection, the diagonal reflection in t to be that value. So I'm going to take element of matrix.add_i.add_j, so that would be row I column j of the matrix goes into row j column I of t. And there we go. So we'll try that out. Okay, so skimming over it, it looks like it's working, and I just need to do a little bit of testing. Okay, so the testing I'm going to do is I'm going to add, I'm going to see what happens if I add one more row or one more column, and then, so that means I'm working with a matrix of 3 rows and 5 columns. Okay, the alignment is sort of nasty, but it does look correct. I'm going to see what happens if I add another row, and I'm just going to paste an extra row in. It's going to be a duplicate of a previous row, but I just want to verify that this works. All right, so the original matrix, we'll make the output window bigger. The original matrix is 1, 2, 3, 4, 10. That's the first row. And then 7, 8, 9, 0, 12 is the third row. And then 4, 5, 1, 6, 11 is the fifth row. If I read down the columns, I do get the right values, although the alignment is pretty bad. That looks good. Let's try making it 4 rows and 5 columns. Okay, a spot check tells me that that's looking good as well. Now let's try reducing the number of columns a bit. Let's make it 2 columns. I'm eventually going to want to see what happens if it's only one column, because I want to make sure that it works even in sort of unusual edge cases. Now, ChatGPT probably could help me with this. It's unclear whether that would speed this up that much, because telling it what I want requires typing out a sentence, whereas backing up some stuff in my text editor doesn't take very long. It looks like this works as well. And then finally, what happens if I have only one column? Okay, that works. And then what happens if I have only one? Well, what happens if I have only one element? So it's a 1-by-1 matrix. That's not going to be very exciting, but I do expect it to not crash. Okay, that worked. And then finally, what happens if I have only one row? So I'll just do this row here. All right, it looks like it works. That was great. I like that exercise. Instead of doing the other ones, which seemed neither here nor there. I mean, Pascal's triangle I already did. This one, it's just sort of brainstorming. I think what I'm going to do is I'm going to say, let's do more functions like that. That was great. Can you generate an expanded version of that template that with 2 more functions added for me to write? Don't show me the solution. And then I have to make sure I ask it as a question. Absolutely. Okay, here's the expanded template. There's transpose matrix, there's print matrix, there's is symmetric. Okay, that's good. Oh, I'm gonna pass on this. There's multiply matrices. So we've all written matrix multiplication before, and I don't know, without spoiling anything, we might need to do that later in this course. So I think I'm gonna hold off on multiply matrices. What I'm gonna do is I'm gonna say I don't want to write multiply matrices. Can you rewrite the template to replace that exercise? Still don't show me the solutions. I'm gonna let it think. Certainly. Okay, here's, I guess, a replaced version. Is symmetric, flatten matrix. Okay, that's interesting. That's actually a nice exercise. It's a good way of combining together I guess the different types of vectors that we're using. So what I'm going to do is I'm going to copy everything below. No, I'll just copy the whole template. I'm going to copy everything and then keep my own code. So I'll bring this in. I'll overwrite my main with the new code. I'll just go up and I will delete these placeholder, all this stuff, because I already wrote print matrix and transpose matrix. I'm going to also make the editorial change to remove the ampersand and the const qualifier, although they are valid and they actually would be a good idea to use in this context. We just haven't seen them yet. Now, I think I know what flatten matrix means. So flatten the matrix into a single vector. I read this as saying, take the matrix, this two-dimensional thing, and make a one vector that's just 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, in case I didn't know that, we actually can ask ChatGPT to tell us. Can you write a header comment for flatten matrix containing a formal specification for that function? And here it is. So it said a bunch of stuff. I'm going to ignore most of what it said. Here is a formal specification for the flatten matrix function. Sort of the thing, I mean, hopefully, I haven't read it, but hopefully it's along the same lines you might see on a midterm question. So I'm going to add that there. Is symmetric, to be honest, I sort of know what that means, so I'm not going to bother with, I'm not going to bother trying to figure that out. Is symmetric is asking if the matrix is the same as its transpose. So that is to say, if the matrix is symmetric across its diagonal. You know what? I will ask for a specification. Can you also generate a header comment with a specification for is symmetric? Okay, so we'll scroll down. We'll bring this in. Just grab the whole thing there. Okay, I'll just copy the whole thing and then head over here. There we go. All right, so is symmetric returns true or false. I'm going to do one more thing. I'm going to compile first to make sure I haven't broken anything. Okay, just these return statements missing. That's fair enough. Is symmetric returns true or false. It returns true if the matrix is equal to its transpose, so if it's symmetric across its main diagonal, and it returns false otherwise. What I'll do is I'll basically mimic a lot of the same logic that I used in transpose matrix, I'm going to copy the complete code of transpose matrix and then delete some of it. All right. So the way I'm going to approach this is I'm going to compare every element that isn't on the diagonal. Well, actually, I can even do that, but I'm going to compare every element with its reflection across the diagonal. So I'm going to delete this code here. I'm going to recycle the loop that I was using for this. Basically, I'm going to loop over my matrix, and well, actually, wait a minute. Okay, one other thing I should consider. It's not possible for a matrix to be symmetric if the number of rows isn't equal to the number of columns. So if the matrix isn't square, then it's not symmetric. So I'm just going to take care of that case right off the bat. Okay, so if the number of rows is not the number of columns, we're done, return false. Otherwise, I've got this matrix that's square. I'm going to look at every element in the matrix, and I'm going to look at so here's the diagonal. I'm going to look at the element on the corresponding element on the other side of the diagonal. So for every entry ij, I'm going to look at ji. If those two elements are not equal, then it's not symmetric. On the other hand, if I get all the way to the end and I haven't found a case where it's not symmetric, then it is symmetric. So I'll return true at the end. In the meantime, I'm going to say if matrix.at_i.at_j is not equal to matrix.at_j.at_i, well, then the matrix is not symmetric. So I'm going to stop. I'm going to return false. I think that's our implementation of is symmetric. I'm actually going to defer testing this until I've written flattened matrix, because what I would like to do is ask ChatGPT to help me with my testing a bit. Because it is good to do your own testing, but we already did a bunch of testing. We sort of know what to test. It's going to be tedious if we do it ourselves. That's why ChatGPT is here to help us automate things. So what does flattened matrix do? Given a matrix represented as a vector of integers, this function flattens the matrix into a single vector where the elements are placed in row major order. Now, I know what row major order means. It means you go row by row from the first row to the last row, and you take everything in the first row, then everything in the second row, then everything in the third row. But if you don't know what that means, we can always ask. So I can say, I don't know what row major order is. Can you give me an example of an input and an output for the flatten matrix function? Certainly. Okay, we'll see what it comes up with. So there's our input, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see the flattened output is every row, first row, then the second row, then the third row. So this is actually a nice exercise, not only because it's a good way to combine different types of vectors, but also because it isn't that tough once you get a handle on it. So what I'm going to do is I'm going to make a vector to contain the flattened result. I'm going to call it result. Then I'm going to loop over all the rows and columns of my input matrix. I'm going to go and I recall that I also looped over those things in print matrix in a very convenient form. I'm going to go grab my loop from print matrix, and I'm just going to bring it down here. So I'm going to say grab each row out of my original matrix and then add it to result. Or iterate over the row and add each element of the row to result. And when I'm done, I want to write return result. Now, how do I test this stuff? Well, I could try running the code as it's currently written. That would work. Whoops, I compile it first. Okay, so this matrix is not symmetric, and the flattened matrix is what we expect it to be. Now, I could go in and try fiddling around and making up symmetric matrices and whatever, but that's going to take a long time. I know what I have to do, so why don't I ask ChatGPT to do it for me? Can you rewrite main to contain at least 5 test cases for each function? And also show me the expected output of a correct implementation. Don't show me the solution. Let's see what it can do. Okay, it's going to try. So here's a new version of main. I think it's going to spend a long time generating this, so we'll just let it sit there. ChatGPT isn't actually slow. It's because I'm too cheap to pay for the premium version. Is this 5 test cases? This is 1 test case. There's transpose matrix. There's matrix symmetry. Yeah. I wanted 5 test cases. Please generate code that contains all 5 test cases. Do not leave any test cases for me to write. I apologize. Well, you better. Let's see if it actually does it, though. Yeah, so I think it might have reached a limit of how much code it's willing to write for me. I think that might be the problem. Yeah, okay. So, let's see. Does it actually give any symmetric? Well, we'll try this. We'll see what we can do. It might be that what would be a better idea here would be to ask it just for test cases for one of the functions at a time. Because I suspect that the reason it won't generate more is because it just reaches a limit of how much code it's willing to write for me. So I'll try running this and see what happens. It might still give us enough tests for our purposes. Okay, so let's scroll through. We've got test case 1 transpose matrix. So the first matrix is 2 rows, 3 columns. It tests it out. It gets 3 rows, 2 columns. That's good. Test case 2 for transpose matrix. We come out and we get, it's the same one as before, but it does look correct. Test case 4 is symmetric. Okay, well, this is symmetric, and the answer comes back saying it's symmetric. It's odd notation that it's using, but this is valid notation. This matrix is also symmetric, so it comes back being symmetric. Fair enough. And then we go down and look at flattened matrix. It should be 1, 2, 3, 4, 5, 6, and it is. That's the only test case it gave me. Okay. Well, okay. So we already tested this on a flattened matrix. We tried it on a 3 by 3. Let's do a 2 by 2. I think that might be enough tests for flattened matrix. We know enough about what it does, and we've tried it on matrices that are square and matrices that are rectangular. I guess I could try a different kind of rectangular matrix. Okay, we'll do that. Okay, it looks like that worked. And then with is symmetric, so we tested already on a non-symmetric matrix, and we've got these 2 square matrices that are symmetric. Let's see what happens if I give it a rectangular matrix. So we know this should fail. Okay, tab that in. We'll see what happens here. So this is test case 2, I think, that I've modified. Not symmetric. Okay, that's good because rectangular matrices can't be symmetric. Now it's symmetric again. Let's see what happens if I change it so that it isn't. We'll modify an element so it's no longer symmetric. We'll try testing it out. It looks like that works. Okay, so I think we have also done enough test cases to verify is symmetric. All right, so there are exercises on nested vectors, vectors of vectors.